what are you going to view? Let me tell you one of the secrets of the universe here. How to estimate sidereal time. As the Earth moves around the sun, every night at midnight, we're looking out at a different section of stars. And as we move around, we're seeing different stars. You can see them move throughout the sky week after week. Well, somewhere long ago, they divided that 360 degrees, they divided it into 24 hours. That's called the sidereal time. This is also where the right ascension comes in. Now, this is pretty, there's a lot of reasons for doing that. This was way back before we had the computers and all this fancy stuff. You can actually set a clock. You could get your equipment pointed straight up. Pointed straight up, remember what I said was straight up, what one of the lines was? That's your meridian. If you know the sidereal time, you know what's on your meridian. Now, the sidereal time, everybody's got all kind of fancy watches and things that'll show you this. Remember one date, September 22nd. Now, we're in November. September, October, November. 24 hours in 12 months. 2 hours per month. September, October, November. 4 hours. Whatever your local time is, add 4 hours to it. And that's, now that I'm out on this limb, who can tell me what the sidereal time is? If we got anybody that's got that on their clock, trust me, go home and check and just see how it works. It is, what time right now? It's about 7:15, 8. So that would mean, add 4 hours, it's 1:15 midnight sidereal time. That means you find objects that have got a right ascension 0 of 12. Or excuse me, that'd be 00, because 8 o'clock on the 24 hour is what? 2000 hours. Add 4, that's 24. So you're looking for objects that have a 0 right ascension. Those objects with 0 right ascension, or a few hours before, a few hours after, are going to be right on your meridian. So if you've just got a list of objects that just gives you the right ascension declination, look at your local time, say, I'm going to be out observing tonight at midnight. Find out how many hours it's been, or how many months it's been since September, or before or after September. Subtract that, or multiply that by 2. Subtract or add. That'll give you or close enough within 30 minutes sidereal time of what's going to be. You don't have to look anything else up. You can take that list, look at your right ascension. If there's somewhere near that sidereal time, the sidereal time is just where we're located in the orbit around the sun. You'll be able to measure through. What's that?
There's a website for that too.
What's the sidereal time?
Yeah, it says it's 23:55.
Okay, that's as close to 2400, and we guessed 2400. So that's so it works. All right, so thank you. I was getting nervous. All right, now you can figure out what your sidereal time is, which is going to tell you what objects are going straight overhead. Now, where is your southern horizon? Now here in this area, 33 degrees above the horizon is the north celestial pole. That means you take the plane, rotate it up 33 degrees. That means if you look at the south celestial pole is 33 degrees below the horizon. And sure enough, 33 from 90 is what, 56? Minus 56 degrees. If you're looking at a list of objects with the right ascension and declination, if you see any object in there that's more than 56 degrees below the horizon, you're not going to be able to see it from Birmingham, Alabama. This will help you limit the number of objects into what you're actually going to be able to see. All right, and also arrange the objects by constellation. I'm one of the world's worst about just plopping the telescope down and start moving all over the place looking at things, because I've just done it so long I know where this stuff is. That's not a very efficient way to look at things. If you'll prepare an observation list for the evening, you want to start over in the west because that's where everything is sitting. You want to see them first. Look at the constellations over towards the west. Find your objects by constellation, work a constellation out, and keep moving back towards the east. You'll see so many more things that way. West to east, and list. Well, people have been making lists for as long as they've been stargazers. And we're going to look at a couple of them. All right, the best thing, if you picked up one of these sky maps, one way to do it, this is a lot of information for the month of November right here in the sky map. It shows you, here's the ecliptic, shows you what you can expect at certain times. And it also gives you this. Naked eye objects you can see, what you can expect to see with binoculars, and also what you can expect to see with a telescope. This is a really good list to start with right here. Start working your way through this, figuring out what your field of view is, how much sky you're going to see through your particular telescope. And it's going to give you some things you'll learn to interpret how bright something is, how dim something is. You can learn a lot from doing something with this one piece of paper right here. Now, one that I particularly like, this is from our brothers and sisters up in Canada. All splendors, no fuzzies observing list. Just a bunch of folks up there are really good observers, and they've made a list of the objects that they think are just particularly outstanding. Here's just a sampling of some of those objects. It tells you what they are, and it gives you the right ascension and declination. Now remember, we just determined that our sidereal time right now is around 2,400 hours. Now remember that it's going to increase going back to the east. So you've got 6 hours this way, 6 hours back the other way. Now usually it's going to be real hazy for the first 20 or 30 or 45 degrees on some nights. So let's cut that back to plus or minus 5 hours. 12 or 2,400 would take you to 5. Going back the other way, that's going to get you back to what, 900? And I'm going back to that one too. But that means that right here, you can expect these to be rising in the east. 12, going all the way back to 5. But now look what else it tells you. This tells you more or less where they are too. You know they're going to be on the eastern side of your zenith or of your meridian. Look at your declination. Minus 37, minus 55, that's going to be real close to the horizon here. Minus 69, that's below our horizon, our southern horizon here in Birmingham. We also got another minus 69 right here, the Tarantula Nebula. You're going to have to go down to the Keys to see that one. If you ever get a chance to go to the Winter Star Party, it's a lot, you can see a lot more southern sky down there. It's a lot of fun.
Hey, Fred?
Yeah.
Quick question. The IDs on the left, because I want to look at some of these.
Yep.
Of course, I know the Messier, the M ones. What are the just numeric IDs? Is that NGC?
These, it's the New General Catalog. The
Okay.
New General Catalog is from the 1800s. That's the new one. These are different designations. These will tell you what you're looking at over here. Like this particular star, 32 Eridani, you can see. And this is just as beautiful, greenish. And they say there are no green stars, but you'll beg to differ when you see this. This particular information here gives you the size difference or the separation, 7 arc seconds. You'll learn the difference, how close or how tight a double is. 7 arc seconds versus 2 arc seconds is real close. Say anything above 6 or 7 is going to be nice and wide, you can see it. But the designations are NGC. And these are just, once again, ways that they can identify this object. And this right ascension and declination, these don't change very often. like every 50 years or so, they'll update this because the stars are slowly moving. They're actually moving pretty good clip, slow to us. And then you got different designations. This is the Large Magellanic Cloud. The M38, this is the Messier. Let's go back to,
There's a question.
what's that?
Go back to the chart.
Yep.
So if I'm now I understand this correctly, Pleiades has a declination of 24, and we with our sidereal time are right at 24 closer to that. Does that mean that Pleiades will be
It'll be on the
right
meridian.
on top of us?
Right, they were asking this particular one, and now what you're wanting to look at is the right ascension. Now the right ascension is where it's going to, like right now, if we were to go out there and look, the right ascension's 3. So it would be, here's our meridian, you want to move about 3 hours back towards the east. And that's where the Pleiades would be right there. But if you waited till 3 o'clock sidereal time, well, just 3 hours from now, or around 11 o'clock or midnight, Pleiades is going to be on the meridian, on that line going from north to south.
So is that what the experts mean when they talk about the stars going in the meridian?
That's it. When they talk about crossing the meridian, now when they cross the meridian, that just means when they cross that particular line. It's also the highest point they're going to be that night. Because any other time they're kind of low to the horizon, but that's as high as they're going to be for the night.
And the horoscope can track it.
It'll track it all night. And some of these really clever alt-ads will do that. It'll track. All this was invented years ago. All this does not require any computers, nothing special. There's also a thing called hour angle. They used to just point the scope straight up. They could figure out the hour angle. The hour angle is just how far away from the meridian it is. They say something's 2 hours away, like we're looking at the 3 hours. They move the scope 3 hours over, and there'd be the object right there. So now we've got all these hypersensitive computers and all kinds of stuff that does a lot more accurately. Is this sinking in? Hit the I believe button, or hit the I believe. Start playing with it, you'll see. Here's the Astronomical League. They've got all kinds of information in here. They've got observing programs. You complete a checkoff sheet, they'll send you a little button that says you've completed their observing program. Here's an asterism program. And let's see, advanced observer, oh boy, binocular observer award, just things using nothing but binoculars. The Caldwell, that's just another list of somebody that said, I'm going to give you a list of 110 interesting things to see in the sky. Now, one of those is going to be the Messier list. Everybody talks about Messier. That's because these are some of the brighter, more beautiful objects in the sky. Here's a piece of one of the Messier lists right here. Here's your NGC, once again, designations. Here's your right ascension, your declination. This tells you what type of object it is, about how big it is, and the Messier designation. He would find different objects. He was looking for, he was looking for comets in particular. And a comet moves from night to night. Well, he found these fuzzy objects that didn't move. So he knew they weren't comets. He didn't know what they were, but he made a record of them. So the next time he came across them, he knew it was not a comet. And here's your right ascension. Say this particular one right here, M29, has got a right ascension of 20. Now we said 24 is right now straight up. So this tells us it's on the west side of our meridian, is where you would find this particular object. That would tell you how far over to the west it is, and then the declination tells you how far away from the North Star it is. And of course, you've got all your computers. As much as I hate to admit it, this is about all I use right here. These things are fabulous. It tells you the different objects. It gives, you can zoom into these things if you want something a lot closer detail you can use for star hopping. And if you click on them, it'll give you the right ascension declination, gives you all the information you need if you want to use a different type of way to find things. Now we talked about one thing this will give you, it'll tell you where on the azimuth, like say it was 90 degrees, you would move, if you've got just a manual scope, you'd move it 90 degrees, and if it said 34 degrees altitude, you raise it up, there would be the objects right there. It just gets a little bit closer in right here. Here's M39, different. This is actually M31, which the Great Andromeda Nebula. It's up there tonight too. Easy way to find is the Cassiopeia. It's got a little arrow on one end. Follow that arrow to this star. It's very obvious. Come out this way just a little bit, and there it is. And all this will be explained in much more detail on our website. Go up to Amateur Astronomy on our website, and you'll be able to start looking through all these presentations. And we got a bunch of other articles on there that explains all this just in a lot more detail. Gives you something you can go back and reference. And I understand we're actually filming some stuff tonight, so you'll be able to see a lot of other stuff too.